nutraceuticals, and we're here to share a dose of knowledge on what works, what won't. We'll entertain you and we'll show us innovative.
Hi, I'm Devon Gold. I'm from Step Change Innovations.
And I'm Todd Runstead from Next USA. And we're the Nutraceuticals. And this week, we're together, kids.
Right?
We're right here in Cleveland and home of the Rock and Roll Hall of Fame. And we're going to be rocking and rolling today. We've got a special guest, an old pal, Sebastian Balcombe, and from Specnova. He's the liposomal guru.
Yes.
And liposomes, as I like to point out, there's the lipo and there's the some.
Lipo. It's all right. Just
Is it liposuction? I always called it liposuction. Kiss me on the lips. They're fat.
Oh dear.
Should I start calling these lipes? I will bow to the PhD.
Context.
Right. Lipo.
Lipo.
Is it liposuction?
Well, let's ask our guest and ask him how he pronounces
Let's hear it from the horse's mouth. Oh my God, is this going to be an
Don't
Orlando?
question a horse?
I know.
Sebastian, before we go here,
Throw me under the
who's
bus.
sexier, Orlando Bloom or Johnny Depp?
I would have no idea. I think my kids would probably go with, at least for like funniness, Johnny Depp. But I don't know. I wouldn't be the best person to answer.
I heard Johnny
answer there.
Depp.
I think they're
Booyah.
both handsome guys.
I am the
I see
ingredient queen
Devon,
for the
Devon
day. I get to
shaking
wear
her
the
head.
sash.
Oh boy.
Okay, and now because I'm magnanimous, Sebastian, how would you pronounce that word?
I usually say liposome.
Damn it.
But
Okay.
it is all over. I mean, it can be lipo, kind of however you want. For sure, it's talking about the fat portion of the phospholipids, so it can be kind of used either way.
I'm going to go home to my wife and tell her, kiss me on the lipes, and see what she says.
Sorry,
Oh.
Jen. Trying to keep him under control. Well, before we jump into liposomes, so
Yes.
we invited Sebastian here because you know a ton about improving the bioavailability of the clinically efficacious doses of science-backed ingredients that we love to talk about so much. So can you talk about why improving the bioavailability is important for both consumers and formulators?
Yeah, I mean, it's very, very straightforward. For consumers, it's all about efficacy and performance of the ingredient. That's all they really care about. They don't really care how you get there. They just want to use a product or an ingredient that does as it says, and whenever possible, exceeds expectations. That's always the goal for me in the natural product space, just because while we have some great ingredients, there are a lot that fall short, and it's almost always because of bioavailability. So
Right.
from a
And
consumer
is that just
standpoint,
because of
that's
like
it.
large molecule sizes and they don't get into the cell? Is that kind of the issue?
Like molecular size, weight can definitely be a factor. But most natural product compounds, I mean, it does vary so much, but most of the plant compounds that we deal with, vitamins, minerals, single amino acids, molecular weight or size is not the issue. Um, it's it's usually their water or their fat solubility characteristics. Those are the limitations. Because again, this is a general rule, but there's a rule of five that we generally use, and one of those rules, or it's called Lipinski's rule of five, that he had come up with,
Now, is
is
that Lipinski or
Knew that was coming.
Lipinski, Liponsky, is to keep anything under 500 molecular weight is the ideal size to fit through the small intestines. And most natural products like vitamin C, most of them are below there. There are some exceptions like B12, where it's 1,300 molecular weight, but most single amino acids, 150, 200 molecular weight. So that's not so much the issue. It's really the fat, water soluble, and water soluble characteristics.
Molecular weight would be an issue, like if it's like a transdermal patch or something, though, right?
It's
Isn't molecular
both.
weight a consideration there too?
Yeah, it's both for sure. That rule of like the 500 or less on topical really um, holds even more weight. But then there's really no set exact rule, even though these are like guidelines and they usually most of the stuff fits within there. There's
Mhm.
ways to manipulate. There's ways to make cell membranes larger so things can slip through. There's literally topical liposomes that we also work on as well. They're totally different than liposomes that you ingest orally. Um, they're more flexible. They can get through the skin easier. So there's always like ways to kind of tweak things.
Yeah.
Yeah.
So, when I think bioavailability problems, like the first three ingredients that come to mind are curcumin, CoQ10, CBD. Look, there's the C's. The C's have it.
Yeah.
And so
Yeah.
what's the story with those three? And because I would always think in my head, oh, it must be the molecular size of those, like they're just big. But like, is that the case with them, or am I just half-assed wrong and
It's
it's something
those
else?
are great examples of highly overly fat soluble or nonpolar or lipophilic compounds. That's their issue. They have terrible water solubility and they have incredibly high fat solubility. So that's their weak point. Especially like CBD, and not just CBD, but the range of cannabinoids. That was something we worked on early days with Specnova, where we were working on making it much more water soluble and stable. And that was a really interesting hybrid system that we did, which was a mixture of being liposomal, but also we complexed them with cyclodextrins to really help make them more water soluble. So yeah, there's always like very custom formulations per ingredient. It's just not one size fits all. Um,
So with those,
yeah,
like, would it then help if you just like took a spoonful of peanut butter when you took them, and there was enough fat in that peanut butter that would kind of get you through the night?
it's like most natural product compounds will absorb better with like a fatty meal or just like what you said, but it's still not the same as a liposome. Liposomes, think about them like this. They're amphiphilic, which is they're water and fat soluble, so you need both. It's a balance. Whereas a fat, of course, is fat soluble, so it's not really addressing the water soluble characteristics that you need to absorb. Because think about this: you ingest something, it goes into it gets to your stomach. Your stomach is water, right? It's gastric acid. It's a water soluble environment, so you need whatever you take to disperse and be soluble in the stomach before it even gets to the small intestines, because if it's not, it's like these big globs of that ingredient, and then it won't get absorbed properly or optimally in the small intestines. And then the small intestines, the wall is mostly fat soluble or fat permeable, so if it's too water soluble, then it doesn't cross the barrier. So you need both, the balance between the two, and that is what a liposome is.
Hmm.
It's so
Yeah.
interesting.
Right.
We're such complex creatures. So we
Yeah.
know that liposomes are obviously going to improve the bioavailability of whatever active we're talking about. But does improving bioavailability necessarily translate to improved benefits for consumers, and how do we determine that?
Yeah, it definitely doesn't. I've talked about this for years, because our industry often just takes the ball and just runs with this crazy when they show an increase of whatever that ingredient is in higher concentrations in the blood plasma, and then they want to make everybody think that equates to better uptake of the tissue, better performance, all of these things. So it definitely does not always equate to efficacy, better efficacy. And there are times when it can be a disadvantage, especially when a formulation is just focusing on trying to get that ingredient into the blood quicker. That's not the right way to go about it. A lot of the time, you want to slow an ingredient down. So there's so much nuance to that, and it's also why when you look at our clinical studies, like on and Todd, you know, CoQ10 was one that we actually have done a clinical on it. It's in peer review. Some of the strongest results we ever got from liposoming an ingredient was with CoQ10. Berberin was another one, which is also completed. And it's just, we didn't just look at, you know, bioavailability, which for the listeners, because sometimes there's some confusion on what the definition means. It's literally how the amount of the compound, whatever you took in your mouth, that got into the blood. So the fraction that's in the blood. It
Right.
doesn't mean that it gets from the blood to the tissue. It just means that it got through your GI tract and into the blood at a certain percentage of what you ingested.
Which
So,
is great. That's a start,
yeah,
right?
it
But
is a
then it's like,
start.
okay, what's the clinical endpoint? What does that
Exactly,
call for?
exactly. So
You got to
you'll
test that.
see, like with our published liposomal vitamin C study, we looked at actual endpoints where we looked at concentration of vitamin C or ascorbic acid in immune cells, in white blood cells. So we didn't want to just show, okay, there was this big elevation in ascorbic acid versus non-liposomal, and it lasted much longer, over 24 hours. It stayed elevated, which is a big thing that we really focus on, over 24 hours, not these small little snapshot windows where they're like showing some big spike of the ingredient in the blood for like 2 hours or 3 or 4 hours. It's really not very meaningful. So we'll do blood draws over 24 hours, and that's what we see: much higher concentrations in the tissue that we are interested in. So that was like that was like a bioavailability study, which all the great PK data, you know, what people are used to seeing, area under curve, Tmax, Cmax. But then we looked at concentrations of it actually getting into the white blood cell for immune benefit.
So
Yeah.
cool. So
Yeah.
liposomes are really changing the game for supplements, but of course, you know that not all liposomes are equal. And I want to give you a minute to talk about this because I know that's something you're really passionate about, making sure that when you say something is a liposome, it is indeed a liposome. So, floor is
Yeah.
yours, my friend. Tell us your
Yeah,
Yeah.
thoughts.
because there's the liposome game, and then there's the nanoparticle, right? And but there's a specific definition of nano, like it's got to be under 100 Daltons. Is
Yeah.
that it?
And but nano would be a drug, right? Or does
No,
it?
like
No.
nano's just a measurement, it's just a
Yeah.
size. So and there is some, you know, debate on what is nano size. Typically, if you look at all the literature, I would say anything under 300. Some will say anything under 200, but anywhere from like 200 to 300 nanometers or less is nano size. And almost all of our liposomes, depending on what's inside of them, will be just naturally nano size anyway.
Sure.
Because like like vitamin C is something like 60 something nanometers. So the liposome, everything around it is still way below. Like we measure them when we look at them through cryotem, and they're usually 100 to 150 nanometers. So with a few exceptions, like vitamin B12, which is such a monster structure, we
Yeah.
obviously can't make a liposome smaller than the molecule that's around,
Yeah.
that's inside of it. But for the most part, they're nano size, and that is a benefit for absorption in the small intestines. More surface area against with the small intestines wall, just better distribution, can help in solubility as well. So
For
that is a benefit. But to address your question, and then actually to answer your question, your very first question, Devin, which was, you know, not just what it matters to customers, but what it matters to the formulator.
Yeah.
The formulator really helps because they can often use smaller doses.
Yep.
That's a huge advantage. While it doesn't erase, or you know, the flavor profile of some pain in the ass ingredients that might smell or have bitter, you know, stringent tones, it does help reduce some of those tones and smells. And then for sure, like if it's in a drink mixed powder, maybe you have like a green powder drink, and now you want to use liposomal berberine or whatever you want to use of ours. which has horrendous solubility. Now it can stir and
Yeah.
actually be a much nicer consumer experience. So it's good for the consumer. It's good for the formulator. So there's a ton of advantages too there.
Would that help for beverage applications? And I'm thinking like with herbs,
Mhm.
like botanical components, which are really difficult to keep suspended in
Yeah.
beverages, so
Yeah.
you would have to like shake it, which has
Yeah.
its own issues. But would a liposome help that to enrobe the plant
They
particles?
they
Yeah, it
work in
does.
mixes, right? But not as much. Are they stable in ready to drink?
Yeah, so that's exactly right. So the stability of liposomes, they're liposomes, like people think they're, we're like putting them together. They come together through their physiochemical properties and they self-assemble
Hmm.
and they're held together mostly with what we would consider weak bonds, which are hydrogen bonds. So
Yeah.
you throw these things in water, there's obviously they pull
Yes.
apart. It doesn't take very long before, like we're talking usually a couple weeks before the liposome will fall apart. So we do better, like we'll do very specific formulations if there's like an RTD application. And usually that will be with like a cyclodextrin, which will really keep it encased and keep it suspended. And just like you said, homogeneous in that RTD drink mix. So if you were just to take it and put it into a shaker, shake it up, yeah, the suspension, it will be much more homogeneous and much nicer experience. It won't all settle. But if it's sitting in an RTD, we will tweak a formula to make sure that it's not just purely liposomal, which will fall apart in a couple weeks.
So could you put a liposome inside a cyclodextrin?
Yeah, we'll do a mixture.
Nice.
Exactly. So we do
Cool.
hybrids of complex cyclodextrins with liposomes. Like for example, our ashwagandha, our nootropic ashwagandha, we call Nuganda.
Yep.
We made a version for a company that wanted to put it in chocolate, and we needed to really blunt those bitter tones of a lot of the
Yeah.
ethanolides,
Yes.
which cyclodextrins are way better at doing than a liposome. So we basically did a hybrid, a liposome and a complexion with the cyclodextrin. So yeah, the ingredient is complex or just connected to the cyclodextrin. Then we spray dry and liposome it. So yeah, we do a
So
mix of
would
them.
Makes me science
would
very
that help?
happy.
Yeah, right. Well, because I'm thinking, when you just mentioned berberine, right? Nature's Ozempic, as it's
Yeah,
called. And
Bullshit.
I know, I
I
know,
never called it
I
that.
know, but it's still out there. And
Yes.
so, but I'm thinking, oh, you take berberine and you can put it in a shot, and it's like, oh, here's your like weight loss shot. And
Mhm.
and so for the people who don't read those tiny little labels to say, shake, maybe you wouldn't need to shake because it's enrobed in a
Yes.
liposome in a cyclodextrin in
Yep.
the berberine in the middle, and then that would work. Yeah.
Absolutely. And then Todd, bear this in mind. If we're talking about those little shots,
Yeah.
um, depending on if they're like a water base, then we need to do what I just said. But if they're more like a glycerol base or they're more like a fatty gel type thing, the liposomes are beautiful in those. We don't even
Yeah.
need to do cyclodextrins. They can stay stable,
Yeah.
especially in like the gels. I mean, you don't need to do anything with cyclodextrins
So
at
when I'm
all.
thinking, when you say gels, I'm thinking like those little like sports gels
Oh,
things,
like
but
goo
Yes.
energy or
yeah,
something.
Yep,
goo,
Yeah.
right, right.
exactly. Yep, goo
Yeah,
energy,
right.
that would be an example of one. But even some of the little shots, like you were just saying,
Yeah.
they'll often have like a glycerol base. They're not
I've
all
seen that
water
done. Yep.
bases,
Yep.
too, so they can work as long as they're not just like a pure water base.
And so forgive me, but like a glycerol base, is that still going to be like liquidy,
Yes.
watery?
Yes,
Maybe a
yes,
little
yeah,
more viscous, maybe.
Yeah. A little more
yes,
mouthfeel.
yeah.
Yeah.
And I should do a caveat, like we can and have done our liposome in water or aqueous formulations and they're stable, but we have to work with that partner so specific on everything from like the temperature is processed at, the pH that is processed at, making sure there's nitrogen filled. Like we can do it, and we have done it. It is the most difficult thing with liposomes, though, to keep them stable in a water format. But we have done it, and we're working actually with an amazing contract manufacturer that specializes on liquids because I know in the industry, because we tested so many liquid, quote unquote, liposomal products, and there were no liposomes present ever. Not one did we test that there were. So this is
Well,
something that we're addressing, and we're solving it. So it is challenging, though.
It's so cool.
Yeah.
yeah. So two things. One is there was this concern around core natural product shoppers. When you throw out the word nano or nanotech, they think that's
Mhm.
some sort of evil, mad scientist, sort of ultra processed food sort of thing. Stay away.
I know.
That's like a hurdle, right? And then the other hurdle is for some ingredients where consumers learn, like, oh, I need to take 100 milligrams of CoQ10. Oh, I
Yeah.
need to take the 90 milligrams of vitamin C. Whatever it is, where they have it in their head, where it's more or less known that it's like this is how much you need to take. Then all of a sudden, when you have a liposome, and it's like, oh, this has the same effect as 100 milligrams CoQ10, but we're
Yeah.
delivering it in 30
Yeah.
milligrams, and
Yeah.
then that takes some education around that to tell the consumer, no, this is as good as the 100, and maybe it's even better because it'll absorb.
Yeah.
There's that needs to happen. So there's education to sort of clarify the benefits. I mean, do you see that
There
challenge?
is. Yeah, there is. Like the nano thing isn't that difficult, because nano is just like saying like there's a negative around a measurement like inch or you know what I mean? Like that's all it is. It's just a
Right.
measurement. Like, um, when the word tech is tacked onto it, I definitely think that makes it more like that confuses people, because then they're
Right.
thinking, biotech and all this kind of stuff. But nanometer is again, it's like inch or centimeter. It's
Right.
just literally a measurement. So we haven't run into having to educate too much on that. For sure, the dosing, like you just said, is something that we have to educate. But that's the beauty of the clinical research that we run, where people can look at it and say, "God, I don't need to take all of that dose, and to get us. Not only can I take less, but I can take less and get a stronger effect than I did at taking that higher amount."
Right.
So it's a recalibration. But we've been in the industry for so long; we've seen so many things change, especially when it comes to dosing. I mean, using creatine as an example, I started using creatine when I was 17 years old. So 27, 28 years ago or something like that. We were taking 20 plus grams a day,
Wow.
and we were all focused on that, the loading phase. you know then research came out that showed, lower doses, 3 to 5 grams, work just as well for muscle performance, but it would take longer for it to saturate into the cell. Instead of maybe a week or two, it would reach that ceiling at maybe 30 days or a little bit longer. So it's been all over the place. And now you see people now they're suggesting higher creatine doses again for cognitive function. So
Yeah.
there's
8 times.
definitely, like, the consumer, as long as the science is showing, the doses and the rationale behind the different doses, then that's been sufficient. And that's what it's been for us with a lot of these ingredients. But there is a recalibration, a kind of a cognitive recalibration when it comes to liposomes and dosing.
Now, that plays really well into my next question, because I wanted to shift gears a little bit and talk about the Nova Q sphere technology
Yeah.
that you have,
Yeah.
which I take the Body Tech
Oh, yeah.
creatine product, which is actually 2.1 grams of creatine as
Oh,
opposed to the
Yeah.
5. But yeah, and I do want you to talk more about that technology,
Yeah.
but it's so interesting because, even I as a scientist wonder, 2.1 grams versus 5.
Yeah.
I'm an N of one, but I've done both, whether it's
Yeah.
5 grams in my smoothie in the morning, or I take the pills, whether all at
Yeah.
once or spread over morning and evening, and I still get the same benefit. And even
That's
though I am also an N of one, it's interesting because I have a tendency to get night sweats more if I take the creatine in the morning versus Sebastian's wonderful invention. So
Mhm.
very
there
interesting.
you
But
go.
anyway, tell us more about the Nova Q
Well,
spheres.
hold on a second, because I think that's really interesting, because there's this math thing
Yeah.
where obviously this liposome technology is going to cost more, but you're
Yeah.
using less
Yes.
of the substance of the
Mhm.
bioactive. And
Yeah.
so, like do the math, is it worth it? But then there's this other aspect of efficacy. So
Yes.
you're saying it's like, yeah, I'm taking
Yeah.
2.1 grams and it's the equivalent of 5, which is great, for like muscle
Hmm.
building, but you also seem to have this effect on hot flashes, on the power
Yeah.
surge,
Yeah.
which, we can discuss over whether that's good or bad. But so I think so there's two things.
Yeah.
It's three-dimensional chess
Yeah,
suddenly.
but it's
It's
so, I mean,
true.
that's what I love about liposomes, though, is because, I mean, you're making it more efficacious, but as a formulator, like that's why I asked you that question, because I wanted you to say we have to use less in it. And especially if it's something that's bitter, like ashwagandha, having
Yeah.
less to deal with and less to formulate over is huge. And especially in the supplement industry, where sometimes our capsules are really small, being
Yeah.
able to put a smaller dose in there gives us more flexibility on how we can do things. We can put it potentially in transdermal. We can put it in oral strips and things like that. So
Yeah.
just makes
Yeah.
things so much more flexible.
Yeah, and it's not like sometimes we have to address this all the time. A formulator will think, okay, I'll use a smaller dose of the liposomal ingredient. I'll offset some of the cost, just like Todd
Mhm.
said. Um, but then when they're doing the math, maybe they see, okay, you know what? I could just, at least economically, I could just use way more of the non-liposomal ingredient and get the same effect at the same price. But that's where they're wrong. There are complete limitations in absorption for a lot of these ingredients. There's saturation, there's transporters that get oversaturated, and you don't just throw in more of that ingredient and get the same effect, even as a lower dose. They're not equal, even when it's a lower dose. Like the lower dose typically blows that higher dose out of the water, regardless of how much they increase it. So it's not just like the economics of lowering the dose, comparing it to a higher dose. It's really about efficacy, and the companies that really get it because their customers love it so much more, like they'll go to town and be so successful with it. For the other ones that just have this more simplistic idea of like, I'll just put in dose the ingredient higher, and forget about the liposome. That's the past. That's what we were doing back in the day.
And that's why it's so important to not just look necessarily at bioavailability and dosing, but also
Yeah.
those clinical endpoints and figuring
Yeah.
out like what does
Right.
efficacy mean in the
Yeah.
first
That's
place.
right.
That's the money quote right here. Things are
Yeah.
getting hot in here.
Yeah.
Nice,
That's nice.
Sebastian. I like that. That's really the
So
story. So
yeah.
it's that three-dimensional chess where it's
Yeah.
not just like a one-to-one. It's like, oh
Yeah.
well, I could spend the same amount of money on
Yeah.
5 grams versus 2.1. So why bother?
Yeah.
Yeah.
Because the efficacy.
And I'm gonna add a fourth dimension.
Oh my
Now
God!
now we're
Yes,
going 4D. Um, uh,
Scotty, beat
and
me
let's
up.
just
I
let's
am the
just
meat
keep
and
on
an
using
intellectual
your
sandwich here. I love this.
let's stick with berberine, for example, but this will go across a lot of botanicals. Um, a lot of them, especially as you increase the dose, you get major issues like GI issues. Like berberine's a real pain in the ass. Like I've taken it
Right.
for years, taking I know literally a gram and a half, and it can be pretty jarring on the GI tract. So it's much more gentle, right? Way more gentle with a lot of these botanicals, and that's something that's really meaningful to the end consumer. And then the other thing is, um, not specifically with like single compounds like berberine, but what if you're taking an ashwagandha, or like you said from the beginning of our discussion, a turmeric or a curcumin, with a whole range of compounds. Some of them have really nasty toxicity. Do you
Yeah.
really want to just keep on increasing the dose and getting the ones that you didn't want that have toxic qualities about them, and you're increasing those? Just the opposite. So there's also safety benefits as well to liposoming something, which is counterintuitive to a lot of people. They're thinking, oh, you get more of what you're taking into the body, but you're honing in on the specific compound or compounds of interest. You're not just trying to go, gun, basically like shotgun the whole thing. So there's benefits there on the safety side of things too, as well as just like, again, just being gentler on your stomach, easier on the GI tract.
That's an important point. I
Yeah.
mean, we hear talk about turmeric and curcumin and all that all the time, and maybe I know this because I'm married to a hepatologist. But too much curcumin it can
Yeah.
cause hepatotoxicity, or
Yeah, yeah,
killing your liver off. So,
right.
Yeah.
that there is a safety issue there. So if we can be more
Yeah.
efficacious with what
Exactly.
curcumin we're giving, then
Right.
Yeah.
More
huge
efficacious and
benefit.
more safe. Oh my God.
Yes.
Yeah, exactly.
Right.
The safety profile as well. That's a big thing, and there's definitely very good examples. Like, turmeric curcumin is a great example of that. Um, you know, not saying it's legitimate or not, but ashwagandha's fallen under the same light. You've probably seen the stuff
A
in
little bit.
Europe. The word,
Yep.
and lots of herbs do, like, where at least there's concerns there. So this alleviates a lot of those concerns
Wow.
as well. And to address, like, the obsession with liposomes and encapsulations, yeah, we wanted to, like, validate the living hell out of these things. We wanted to show people that they are in fact getting liposomes. They're not just getting a phospholipid source like sunflower lecithin mixed in with the ingredient and then us saying it's liposomal. That's a far cry. So we have spent 7+ years just understanding how to validate them, how to see them, how to characterize them. We've really pushed the envelope on the validation process, and we've tested a huge chunk of the industries along the way, and people want to know that they're paying. If they're going to pay them extra money, then they want to get the better performance. They want to know that it's actually a validated liposome. I know it seems so simple, but it's completely gone under the radar in our industry, the testing part of the liposome. So it's something that we really, really focus on. And we've even done, like, one of the questions that we got, and I was kind of doubtful to it, was, okay, yeah, you're always validating your products are liposomal before they go into a finished product. But what about, are they still intact liposomes in a finished product? And what about a really difficult one like gummies, where there's temperature, there's shear, there's all kinds of stuff going on? So we took one of our customers, I just purchased it, their our liposomal vitamin C in their gummies, and we went under the microscope with it, literally cryo-10 microscope, and we saw intact liposomes in that finished on-the-shelf gummy, which I was even pleasantly surprised because I didn't know if they would still be intact after that whole process. So they are still intact in that finished product that you're buying off the shelf. They didn't just go in as liposomes and get destroyed in the process.
That's really fabulous news for gummies. And gummies, of course, are, the leading trending delivery format. And one of the main wraps on gummies is dosage, right? You payload. You
Yeah.
can't quite get as much as you can into a
Yeah.
capsule, or you could stuff into a tablet,
That's right.
About
But
10%.
yeah,
About
right.
300 milligrams or so per
Yeah,
gummy.
right.
Yes.
Yeah. So,
Yeah.
but all of a sudden you have liposomes. Liposomes
Yeah.
is the great answer to solve that problem with gummies, then, right?
I love it. Like, for single ingredients that are liposomed, amazing. Like them putting our liposomal vitamin C, we call it vitasomal C, into a gummy was like a dream come true. I know, getting
Liposomal.
fancy. Too
That
fancy?
rolls right off the tongue there.
That turn you
Yeah.
on to?
I love that.
Yeah.
Liposomal C.
Yep,
Name
it
of
just
next week.
flows. There you go.
Yeah.
So tell us a little bit about the NovaQ spheres. How are those
Yeah.
different from liposomes, and what benefits do those provide?
Yeah, so liposomes we've talked about have all these wonderful bioavailability benefits, and also a hugely overlooked benefit of liposomes is they improve the stability of the ingredient as it goes through the GI tract, which is a massive problem also with a lot of natural product compounds. Vitamin C is a perfect example. You lose a lot of the dose that you take in the small intestines because it breaks down in that alkaline environment into other fragments, and all but one of them are reversible. So you just lose a lot of the dose that you take. So you get all those benefits from liposomes, and you get a slight delayed release, usually a couple hours. It slows the release of the ingredient. But what happens when you want to, increase the release profile of an ingredient over 10, 12 hours? A liposome can't do that, but the beadlets can. So if an ingredient has limitations where Maybe it has a really short half-life. It gets in and out of the body too quick. It doesn't have the desired effect. The beadlets solve that. Again, you can trickle it out over 10 or 12 hours. And what happens if you have an ingredient that because it has such a short half-life, you have to take it 3 times a day. Now you can take it 1 time a day in the beadlet and let that trickle over 10 or 12 hours. Huge advantage. Customer compliance, right? It's off the charts.
Right.
What happens if you have an ingredient which has terrible stability in the stomach and it breaks down and it's no longer in its form where it has bioactivity? The beadlets again. So huge advantages. We often combine some of our liposomal ingredients and then beadlet them. So you can have a liposomal beadlet
Wow.
as well. But then there are examples, and this really ties into it, where not all ingredients benefit from being liposomed, like creatine. Creatine has 99% bioavailability. How are you going to improve? What, you're going to improve 0.5% or 1% by liposoming it? An epic waste of time and money and a gimmick. So we don't liposome creatine, but creatine does have a real weakness in that while it gets into the blood incredibly well, 99%, that's like very few ingredients, natural product ingredients ever have bioavailability like that. It gets in so fast, and then there is a transporter on muscle cells and also nervous cells and throughout the central nervous system that is called CRT1. It grabs creatine and it pulls it into the cell. Now that transporter downregulates, so it stops absorbing creatine because it gets into the blood so quick. So you end up not being able to take the creatine in the blood into the muscle or into the nervous tissue. It then gets converted to creatinine and comes out in the urine in high amounts. So creatine is the perfect example of something you want to slow down as much as you can. Trickle it in. Do not overwhelm that creatine transporter. So that is why we beadletted creatine. And we worked with really the top creatine researchers in the world on this. Dr. Ralph Yeager was involved. Rick Kreider did the study at Texas A&M, and we were just working on formulations on trying to find the optimal release profile of creatine. One version slightly, sustained the release, but not to the magnitude we want. Now we're working on a much slower release version, but this is where the advantage is, because now you can get more creatine into the muscle, lower dose, but you can also potentially increase the ceiling of how much creatine you can get into the muscle. Again, because the saturation of that creatine transporter, it downregulates. That is meaningful. That's a big deal.
That's why I can get away with doing the 2.1 grams in the capsule versus the 5 in my smoothie.
We are deep in the fourth dimension here.
I'm loving this.
I could feel the hair growing on the back of my neck. Very exciting. So let me just circle back. I think I'm thinking krill was the hot new omega-3, and it was because of the phospholipid. Now, not to be confused with the liposome, but it had the lipo. There was phospholipid.
For sure.
Am I supposed to be pronouncing that phospholipid?
No, but phospholipids are often used for liposomes, right? Because they have a polar and a nonpolar end.
Yeah, so think of it like this. You have multiple sources of phospholipids. The one that we use is sunflower lecithin. Now, sunflower lecithin, the one that we use, has a very high percent of phospholipids. Because sunflower lecithin can be used, there's like super low grades, like what you see in the grocery store. It's just used as an emulsifier. It's not used, as a high concentration of phospholipids. So that we'll think of it. That's the source, and then within the sunflower lecithin, you have 4 or 5 different phospholipids. The ones that people are most aware of is phosphatidylcholine, or abbreviated as PC. But you also have phosphatidylinositol, PE. You have phosphatidic acid. A lot of people are familiar with that, PA. You also have phosphatidylserine. So they're all exactly. There's these 5 main phospholipids in sunflower lecithin. So krill, like you said, has, I don't know the whole composition of krill, like what are all of the phospholipids, but at least has one or two of those. And that is a benefit. It will be, in a mix, it won't necessarily be a liposome, but they will help regardless. They maybe have formed even micelles. It just depends on the mix. But it's a benefit, but it's not to the same extent of like a liposome. But the
It's not 4D.
phospholipids, that it's not 4D. It's like maybe 1.5D. Um, but it is the phospholipids that are the major component in a liposome. But there are other ingredients that we have in the formulation, but that is what forms the liposome.
Because you have to do multiple layers depending on whether your active is polar or non-polar, right? To make sure that
Right.
you're getting a center of a liposome where it's happy.
That's right. That's right. And again, I know you guys know, but for the listeners, when you look at a liposome, which is one or more lipid bilayers, you look at the core, the center of it, and this is the water soluble portion of the liposome. And then if you look at the next outer ring, this is the fat soluble portion of the liposome. And why? Because the phospholipids, the heads, which are on the outside of the liposome and also on that inner circle, those are water soluble. That's literally the phosphate group. And then the tails are the lipid group. So, no surprise, the ingredients that are lipid like or water soluble hangs out with like. So that's how they naturally will load up.
Might be
Yeah.
opposites attract in dating, but it's like versus like
Yep.
attracts like in chemistry.
That's right.
Fun
That's
fact.
right.
I was better
Yeah.
at love than chemistry, so go figure.
I'm probably better at chemistry than love, but
Oh,
that's
yeah.
okay. I'm
This is-
doing all
this is
right.
Why we connect, strangely. oddly.
Opposites attract.
That's right. Well, the phospholipids, perfect example. Fatty acid tails, glycerol phosphate, and choline heads. So and both water and fat soluble. It's the perfect example of that, and needing both of them to really be optimal.
So, with all these new technologies that we have out there and ways of helping to improve bioavailability, help lower dose, if you could give formulators out there one piece of advice of working with these different technologies, what would it be?
Really understand the benefits of the liposomes, understand the characteristics of the ingredient that you're thinking of us liposoming or beadletting. We have a huge portfolio, so you can really customize what you're trying to do. Like, don't just take a hammer to this. Like, if you have an ingredient that absorbs really really slowly and you want it to absorb slowly, you don't beadlet it. If you have an ingredient that you want to absorb quickly and its benefits come from it absorbing quickly, like let's use the most basic example, leucine, the amino acid leucine. Everybody knows you want that baby spiking in the blood and hitting mTOR, getting that muscle protein synthesis. So are you going to want to beadlet it and slow it down? No. You're actually ruining, its benefits. So know how the ingredient works in the body, know its therapeutic window, and then know what you like, what would best match your formulation, be it just liposoming it or liposoming and beadletting it. That's really kind of, and that's where like a lot of the formulators creativity comes into it. And we've seen some amazing formulas out there for both the liposomes and the beadlets. We had a customer who launched a weight management product, and it had multiple ingredients, but one of them is just what I had said earlier. It needed to be taken twice a day, and they had real issues for compliance, and it's a weight management blood glucose type product. So a lot of the benefits weren't being realized. So now we beadletted it one time a day over that 10-12 hours. Really big benefit. Yeah, huge benefit there. So I just the way a lot of the formulators think about using our technologies, that always excites me. I can educate on what they do and all this, but really it comes down to their creativity and how they're thinking about combining a lot of these things and that and so on and so forth. So it's been really impressive.
Would it be possible to say you have a sophisticated formulation? Let's just for the sake of arguing say there's 3 different ingredients in it.
Yeah.
And could you put in a single capsule, say one ingredient is a liposome, but the other 2 are not? Is that
When
possible,
you
or do you have to do the whole? You have to do
when
all of
you
it?
ask that, do you mean like liposomal powder with beadlets?
Yeah, yeah.
Yeah.
Well, just in terms of like, say you have one ingredient, like a berberine, that okay,
Mhm.
yeah, you want to have this enrobed in this liposome because it'll
Mhm.
extend its time release
Yeah.
aspect. But there's 2 other ingredients, where they might be, that you don't need them to be enrobed in that liposome, but they'll help with the formulation or differentiate the formulation.
Yes. So if you're combining beadlets with just liposomal powder ingredients, for example, in the same capsule, that is difficult because like when we've seen like in the blending process, the beadlets are settling, and you could get really doses like all
Yeah.
dosing that's kind of all over the place. Where it does work, Todd, though, if you have a single serve, you can 100%, like maybe it's in a pouch, or maybe a stick pack like a liquid IV or something like that. It doesn't matter how the beadlets settle in the powder, like,
Yeah.
because you're taking it one time, one dose, that works perfectly. But if
And
it's, yeah,
the liposomes, they're just a powder, right? So you could mix those with other powdered ingredients and put it in a capsule and be fine.
and it's been,
Yeah.
yeah, it's been done for
Yeah.
forever. We also do some of our liposomes. We'll keep them in pastes or in oils, but we really prefer to dehydrate them down and make them into powders because they're so much easier to use. They're
Yeah.
smaller. They actually use less sunflower lecithin. They're more cost effective, but there are some examples where an ingredient can have a higher load and be a little bit more beneficial to keep it in a paste or in an oily type environment.
Awesome.
Cool.
Yeah.
So it was a big fat lie. Fats are good for you.
That's right.
Some are not, but some are. Let's not malign all of them, and some of
Yeah.
them is really the difference in efficaciousness and in
Yes.
safety. They could really help to create a formulation that sets you apart, that's safer, that's more efficacious,
That's
that's
right.
a lower dose. So that there remains that educational component that you have to get with the brand to tell the consumer that this is why this is better. This is why you want this, right?
Yeah.
And it's back to nature, Todd, too. Like a lot of people hear me speak on them and they think, oh, these are all man made and this and that. But it's how your body wants to absorb nutrients and compounds. Like we would eat a food normally that had fats and proteins and compounds. Um, and you get all these things together. And that goes for vitamins, that goes for plant compounds. You would not normally do what we've been doing in our industry, which is strip out a vitamin or mineral and put it in dry and just put it into a capsule. Well, it's nothing like the food matrix it would normally come into. And that goes for herbs as well. So this is literally like the environment that your body wants to and is accustomed to absorbing, which is again why you see such a benefit compared to like a naked vitamin, mineral, or compound, which is just put into a capsule. So it really is the preferred way to absorb nutrients and botanicals and more.
That's awesome.
Yeah, I know I feel a little smarter today. Thank you, Sebastian, for joining us.
Absolutely.
I learned that I could throw around naked vitamins. I could throw that term around there. That excites me like you cannot believe.
Oh,
I just
dear.
made that up, so I don't know.
That's
So
good fun.
maybe
I'm running with
someone's
it. I'm stealing. And then also, this is really important here. I think I might get 3/4 of a point. Lipids, lips,
yes.
liposomes,
Yay!
phospholipids. There's
Yes.
three lower, and then one has the line over it.
You're doing pretty good. I mean, we talked about
Yeah.
4D, and I'm Dr. D, so I'm only 2D. So you're doing okay.
I got 2 D's in my name. We are 4 D's between. We are 4D people. I think we have a new tagline for the dose
Oh,
here.
dear.
And don't forget the key. Don't forget the key term, Todd. Too. This is a good one to remember. The amphiphilic term, which means water and fat soluble. So that is
Right.
what the liposome is doing. So both
Water and fat
and
living
fat soluble.
together. They
Yeah.
said
There
it
you
couldn't
go.
be done.
There you go.
Disney's going to have so fun with this. Todd and Copper, dogs and foxes and cats living together.
I knew that was
right.
coming. Thank you so much, Sebastian, for joining us. We appreciate you so much.
Yeah,
Yeah, my
thanks.
pleasure.
I am smarter now. I am so happy. We're gonna
Always
we're
happy
gonna
to
have dinner.
share
We're gonna
the
have a quadruple
science
D dinner.
on liposomes or liposomes, as you
Liposomes.
say. Yeah, I think
Liposomes.
More the industry knows about them and really understands them, the more they'll get used. There are a lot of false ideas and narratives out there on them, but if you really understand the science and how they work and where they really transform the bioavailability and efficacy of ingredients, you're gonna love them.
All
Absolutely.
right.
So,
Cool.
All right.
That's good.
I think
Thanks,
all right,
Sebastian.
guys.
Thanks
that's
for
it
Thanks for
us.
your
yeah,
time.
nice little education on liposomes.
Absolutely.
All right.
Thank you,
See
guys.
you next time here on the
See you
dose.
next time.
Have a
Thank you.
great
See ya.
day.
We are the nutraceuticals.